classified as ferrous. Okay, any metal consisting of some component of iron, we call it as ferrous materials, which doesn't contain iron are called as non-ferrous. Okay, again in ferrous there are 4 types: wrought iron, carbon steel, alloy, and cast iron. This we have discussed in the earlier class. And in non-ferrous, there are various examples like aluminum, copper, lead, silver, gold, tin, etc. Okay, non-metals, predominantly 2 types are there. One is polymers, or in a simple sense, I can tell you as plastics, whatever we use. Okay, so there are 2 types: thermosetting and thermoplastics. And the second is ceramics, like glass, cement, concrete, etc. And one more latest class of material is the composite material, which is combination of any 2 materials to get the specific properties. So this we have discussed in the earlier class, right? Again, in ferrous metals, we have studied about classification: pig iron, cast iron, wrought iron, and steel iron, right? What are its applications we have studied. Under non-ferrous metals, what are its main properties we have studied, and its classification, like what is a metal and what is an alloy we have studied. Okay, so different materials and how they are made we have studied. Some of the alloys like bronze, brass, gunmetal, bell metal we have discussed. And finally, in the previous class, we discussed about the application of non-ferrous metals. Then finally, we compared ferrous and non-ferrous materials. Right? At this point, we had stopped in the previous class. What are the major differences between ferrous and non-ferrous metals? Ferrous metals are that which contain iron as one of the main composition, main element. Okay, so wherever iron is there, always the problem of corrosion will be there. In simple words, problem of rusting will be always there. Non-ferrous metals are those which does not contain iron as one of the components. Okay. Wherever there is 0 iron, your gold chain, whatever you wear, rings, whatever you wear, it never gets rusted. Right? It doesn't react with the moisture in the atmosphere. Whereas iron content, if it is there, always corrosion will be a problem. That is why in olden days only they used to use iron gates, right? Because of this rusting problem, frequently you have to paint it to avoid rusting. These days, stainless steel, silver color, it will be there. Stainless steel gates are used. Even after 10 years, you can see that it will never rust. But the iron content will be 0. Okay, ferrous materials will have high strength and of low cost. Definitely, whenever you want to inquire about a gate for your home, a 10 by 10 size gate, if iron costs around 8 to 10,000, SS will be 30 to 40. Okay, so it will be costlier. Whereas the include good non-ferrous metals have good strength to weight ratio, that is lightweight will be always. Okay, but cost will be higher. Okay. So ferrous metals are used in applications where weight is not a primary influencing factor. Okay, one of the examples we frequently discuss, you cannot compare your car with your aircraft, right? You cannot design in the same way, right? Aircraft materials will be different. You need to go to material which will have lesser weight, higher strength. Cost will not be a factor at all there. Whatever is the cost, you need that properties. Same material, you cannot use it for your car. Same car, 10 lakhs price, if it becomes 50 because of a superior material, nobody will buy it. Okay, so when you consider your car, the cost comes into picture. Strength should be high. Weight is not an important factor. Even though it is a little bit higher, it doesn't matter. Like that, ferrous metals are used in applications where weight is not a primary factor, right? Whereas non-ferrous metals are lightweight and widely used for some specific applications. Okay, so as I told you, ferrous metals always are prone to corrosion. Wherever iron element comes into picture, corrosion will be there. Non-ferrous, it is resistant to corrosion. It will never get corroded. Some of the examples I have listed: cast iron, wrought iron, pig iron, whatever we discussed, they are all ferrous metals. Okay, copper, aluminium, zinc, lead, tin, gold, silver, all are non-ferrous. Right? So at this point, we have stopped. Right? So we have completed metals. Coming to the next, ceramics. Okay. So ceramic is an inorganic material, okay, non-metallic in nature, and often it is crystalline. Usually it will be made of either nitrides or carbide material, right? So some elements such as carbon or silica may be considered as ceramic. It is inorganic in nature where carbon is present. Okay, ceramic materials are brittle, right? So they are hard enough and strong in compression, weak in tension. What do you mean by compression? So there is a device called as a testing machine, universal testing machine. If you take an iron rod, you apply the load axially along Okay, this table, how much load it can take up, at what point it fails. This will give you the compression strength. Suppose if I pull it apart like this, that is called as tensile strength. Right? So if I attach two ends and try to pull it, at what point it fails, that is called as tensile strength. Okay. If you compress it, I mean if you press it from both ends, at what point it will get crushed, that is called as compressive strength. Okay. Ceramics are brittle in nature, they are very strong in compression. Wherever compressive strength required is very high, there you can use ceramic materials, but poor in shearing and tension. Okay, they withstand chemical erosion that occurs in other materials subjected to acidic or caustic environment. One of the best example is whatever vitrified tiles we use. That is one of the ceramic. You can wash it with acid. Right? The bathroom tiles, whatever is there, you can wash it with acid. Right? So that is one of the advantage of this material. They can withstand chemical erosion. They will not be affected by any chemical or acid environments. The ceramics generally can withstand very high temperatures in the range of 1000 to 1600 degrees centigrade. They won't lose their property. Okay. They retain their properties. Okay. So glass is often not considered as ceramic because it is amorphous. It's not crystalline in nature. Okay. So when you break it, it becomes a powder. Right. However, glass making involves several steps. Okay, similar to the ceramic, the processing method of ceramics and glass will be almost same, but glass is not a ceramic. Right? Please make a note. Next, we will discuss some of the important properties of ceramics.